Welcome. My name's Tom. I've got a degree in math from UCLA, and I've been tutoring for about 10 years. Today we're going to do SAT practice test number 3. This is the calculator section, so you're allowed to use a calculator, and it's 55 minutes. There's 38 questions. Let's go. Number 1, Marilyn's hike. So we see we've got distance here. We've got time. Notice the straight line here. Marilyn's distance from her campsite after a 3-hour hike or during a 3-hour hike. She stopped for lunch for 30 minutes. Based on the graph, when did she finish her lunch? Okay, well, we know that her lunch was during the straight line period because the distance is not changing. She's sitting down eating lunch. So she ended her lunch right about here, which looks like around 1:45. Let's look at the times. There we go. We've got C, 1:40. Number 2. We've got a table here with ages, and you've got 25 people. The table's a distribution. 25 people entered a contest. The winners selected at random. A female under age 40. Okay, females under 40, there's 8 of them. Male, 2. Okay, so 8 plus 2 is 10. The probability out of the total group, it looks like. So that's 10 out of 25. Which our answer down here is B. Number 3. By the way, you can pause this when I show the problem and write it down if you like, or just try to figure it out on your own. There's the problem, and I'll scroll, and there's the answers right here, A, B, C, D. Now I'll do it. So the graph below shows the total number of music album sales in millions from 97 to 2009. Okay, so sales. So based on the graph, which best describes what happened, the general trend. All right, well here I think we could just kind of look and just go through each one. So letter A, sales generally increase from 97. No, that's not true. It's decreasing, right? So I'm going to cross this one out. That one's no good. B, sales generally decrease. Well, that kind of is true. We do have a little bit of an increase right here, though. So I'll leave that open. C, sales increase until 2000, then decrease. Oh, increase and decrease. Yeah, that sounds better than B. So B's out. Now let's go to D. Sales generally remain the same. No, the sales are not the same. If they were the same, it would be a straight line. So D is definitely out. The answer is C. Number 4. N, we've got f of n. Okay. Linear. What does linear mean? Y equals mx plus b, right? Or f of x equals m, that's your rate, times your n plus some b value, initial value. Well, we don't have an initial value here because there's no 0 for the n value, the 0 for the x. So we're not going to know what that is. But here's what I say. You know what we're going to do with this? We're going to take one of these and just plug them in and see which of these formulas works out correctly. So I'm just going to take the 2 into 1 because 1 is a really easy number to see. So that's why I picked that one. So let's plug that in. So plug in a 2 and a 1. I plug a 2 in here. 2 minus 3 is -1. Nope. 2 here. 2 times 2 is 4. Minus 4 is 0. Nope. 2 times 3 is 6. 6 minus 1. Yeah, that works. Now just to double check, just do 2 times 4. It's a negative something. Okay, the answer is letter C. Number 5. Again, you can pause this to do this on your own if you like. Lincoln High School, 7% of enrolled juniors. 5%. Okay, juniors are what? So 562 times 0.07. And we've got 602 seniors times your 0.05. Now, I kind of don't even really need to use a calculator. I mean, you could. 0.05 times that, we know it's going to be around 30 or something like that. 0.07 times, you could, if you round this to 600, it'd be around 40 or so. So we're talking around 70, right? Something like that. And there you go. We got 69. But let's just say we were off a little bit and we said 42, something like that. Well, you're still around 70. You're not even near 39 or 30. It can't be that. It's impossible. Letter A, that's impossible. So then that's without a calculator. Yeah, we're just going to go with that, okay? I know that's the right answer. 6. Which of the following is the sum of the two polynomials above? Okay, so whenever we got equations like this, what I like to do is just take each term and look at them individually. So let's first look at the x squareds. So 3x squared, 5x squared, so 8x squared, 8x squared. Okay, so C and D are already out. Look how quick that was. And then now the middle term, minus 7. Our answer then is going to be A. I don't even have to do the last. No big deal. Pretty easy. Number 7. This one here, what do you do here? Multiply both sides by reciprocal. So times 5 over 3. Times 5 over 3, that's going to cancel. So you get 20 over 9, which is D. Number 8, the average number of students from 2000. You know what? Let me see if you can get this whole problem first, in case you want to try it yourself. And I'll scroll down a little bit so you can read the whole thing. Now you can pause if you like. All right, now I'm going to do this problem. So the equation y equals mx plus b again, right? Y equals mx plus b. B is what? B is your initial amount. M is the rate of change each year. So here you got your M is 0.56. The initial is 27.2. So our X represents the number of years since 2000. So in the year 2000, I plug in a 0, I have 27.2. Y is the average students per classroom. This best describes the meaning of the 0.56. Okay, that's your rate of change, right? So the total number of students of the school year 2000. No, we already figured out that that's our letter B, which is 27.2. And that's not even, actually this has total number of students, so that's not even the right equation for that, because we're talking about averages here. Average number of students per classroom in 2000, that actually is the 27.2, but we don't need that. They're looking for the 0.56 here. So the estimated increase is a rate of change. We like that. So M increase 5.6. This could be our answer. Increase average number of students. Yeah, that sounds right. Okay, let's just look to double check. Letter D, estimated difference between the average number between 2010 and 2000. No, that's not right, because we'd have to plug in a 10 here. We have a 0, right, for the X, and then we plug in a 10 for the X. Yeah, that's definitely not right. The answer is letter C. Number 9. Nate walks 25 meters in this many seconds, so 25 meters in 13.7 seconds. If he walks the same rate, it's following close, and he walks in 4 minutes. So we don't know what our answer is going to be, but over 4 minutes. So 4 times 60 seconds. Remember, you got 60 seconds here. You have seconds here. So what is 4 times that? Right? That's 240 seconds. Okay? This is approximately what? The number 2. Okay? So you have a 2. So 2 times 240 is what? 480. Okay, so one of our answers, B, is 450. There you go. Of course, you could plug it in your calculator if you want. Take time to do that, but I like to save time as much as possible, especially when the other answers aren't even close. All right, and in that question, the answers were not even close. Number 4. I'm sorry. Question number 10. Still section 4. Here we go. Gravity. Acceleration due to gravity. Mercury, Venus, Earth. Blah, blah, blah. Let's look at this. Okay, so I'll show you the problem first, in case you want to pause and do this yourself. So you got all these gravities. The chart above shows approximations of acceleration due to gravity. Meters per second squared. W equals mg. W is the weight. M is the mass. G is the acceleration due to gravity. Number 10. Now, of course, you can pause here and try this on your own if you like. I'm going to start working. What is the weight in newtons of an object with a mass of 90 on Mercury? So the weight equals 3.6 times 90, right? So when I look at our answers here, what's 4 times 90? 4 times 90 is what? It's 360 or something. What's 3 times 90? 270. So there's our answer, D. These other ones aren't even close to those big numbers. That was Mercury at 3.6. So, okay, number 11. Of course, you could have done that on a calculator, got the exact dollar amount, or exact amount, taken more time. Object on Earth is 150 newtons. What planet would be 170? Okay, so it's 150 on Earth, right? Let's look at our other ones. So you got Mercury, Venus, Earth, all these. Now, when I look at these, I look and I see Venus. Wait, Venus was 8.9, which is less than Earth. So it can't be Venus because we know the weight increased to 170. Then we also know Neptune. Neptune is 14.1. It's not going to be that because that's an extreme amount. So let's just check these other two. So Saturn, what do I have for Saturn? Saturn, you've got 11.1 times something. Okay, so what is our weight? What is our mass? W equals mg. 150 equals m times 9.8. So mass equals 15.3. Okay, so now you do 11 whatever times 15.3. We're going to get 169. And you do 10.7, which is Uranus, times the 15.3. We're going to get 163. So there you go. Obviously, the answer is B, Saturn. Okay, number 12. A function has 5 distinct zeros. Which of the following could represent the graph? Okay, all a zero means, well, you know what? You can pause this. There's that. I'm going to scroll up a little bit. You could see, find your zeros. What's the answer? So how many zeros does this have? 1, 2, 3, 4. 4 zeros. The zeros is crosses the x-axis. So it's not that one. 1, 2, 3, 4. Nope. How about C? 1, 2, 3, 4, 5, 6. Nope. And so the answer is going to be D. But let's just double check. 1, 2, 3, 4, 5. And that makes sense because it ends positive on the negative x and y is positive on the positive x. So therefore, it's going to be an even number. But since we have an odd number, the number 5, therefore, it's going to touch only one time on one of these graphs. You don't have to know that, but advanced students are going to probably know that. 13, here's an equation. Okay, again, what is K? K is your starting value because you put in T for 0. So there's some equation they want us to figure out. Which of the following is V in terms of, okay, so you want to solve for V. So how do you solve for V? Well, first, move everything to the left-hand side. So first, on the left-hand side, I'm going to get an H minus K. Well, now once I know that, I can look at my answers here. I can just say, wait a second. This one's an H minus K. This is H plus K. That's no good. There's an H plus K. That's no good. So now I already know the answer is B or D, simply because we subtract K from both sides. So now what do you do? Now we're going to add a 16 plus 16t squared equals VT. Divide everything by T, divided by T, and the answer is obviously going to be your D here. Number 14, and I'll hold this a second so you can pause and do it yourself if you like. Okay, so the cost of using a telephone is 20 cents per minute. Notice there's no initial one. Normally we've got mx plus b, right? But our b is 0. There's no initial cost here. So it's really, yeah. Well, anyway, y equals mx. Cost per minute. Which of the following is equation cost for dollars in hours of phone use? Okay. So after 1 hour, what's going to be the cost after 1 hour? Well, 1 hour, it's 20 cents per minute. So the cost would be 0.2 times 60. Okay? So 0.2, well, if you think about what is $1, $1 will give you 5 minutes, right? So this is going to be 12 bucks. Now, let's keep going here. So if I do 1 hour, if I put a 1 here for 1 hour, what's this going to be? Yeah, that actually looks like the right answer right there. Let's just go through and double check these other ones. 1 hour, no, because there's no initial, so that one's wrong. Here we put 1 hour. Here, 60 divided by, no, that makes no sense at all. I put 1 hour here, 20 cents divided by 60. That's an extremely small number. Nope, no good. Okay, so the answer is A. All right, let's go to the next one, number 15. So number 15, and you can kind of look at that, and then I'll scroll down a little bit to see the other answers for you. You can pause. So we've got a study. I'm going to do this now. This is number 15. So we got successful at improving eyesight. Okay. A large population of people with poor eyesight. This is the definition of our population. So you got to be careful in that. Make sure you've got a defined population, and we do in this particular case. Half of the participants are randomly assigned. Okay, random. That's the way it's got to be random for choosing your participants. The other half did not receive treatment. Okay. The resulting data showed participants who received a treatment improved compared to those who didn't. All right. So they got some improvement. Treatment X is likely to improve eyesight. That actually sounds pretty good, doesn't it? It's likely to improve. I like that word likely. Okay, it's not a definite word. It's not a strong word. So you're just saying, it could. It's likely. Letter B. Treatment X improves eyesight. See, now that's telling you it definitely improves eyesight. So I don't like that. And then it says, so I don't really like that word improves, better than all others. This is a comparison. And we did not do any comparison to other treatments here. So this one cannot be correct. Letter C. Treatment X will improve. Again, look how strong that is. Okay. Treatment X will improve eyesight of anyone. Well, we didn't test anyone, did we? No. We tested people with poor eyesight. So that one is no good. Treatment X will cause a substantial improvement in eyesight. Again, it will cause, that's too strong of language, and they're not talking about who it is. You need to know your population should be discussed at least slightly in your conclusion here. So, yeah, treatment X is likely to improve in this population, the poor eyesight people. 15, the letter is A. Number 16, here's your graph. And I'll scroll down so you could see the answers and the question. So, the graphs of the function f and g are shown in the plane above. When you add them up, when do they equal 0? Well, when you add it up, that means when the value on this graph is the same as the value on this graph. Well, I don't know. It's like if you took these points, it would be that point plus that point. If you add those two, does that equal 0? No. 0 means your x is going to be 0 here. So where do we add it? Well, I can tell right here. There it is. There it is. Right? You have a positive 2 on this g of x graph. I have a negative 2 on the f of x graph. So what value are we looking at? Which value of x? Okay, so what is the x value here? You go negative 2. X is negative 2. The answer is letter B. '17. Econ. I remember I loved econ in high school. Lots of fun. So here's the problem. And I'll scroll down a little bit. You can try to do this on your own. Number 17. And this is actually for 17 and 18, this paragraph up here. Okay, I'm going to get started. So we've got two equations. I like to, in general, let's just graph this thing. So supply, we have 1/2 plus 40, so it starts at 40 and it goes up. All right. Then the other equation was your demand is 220 and then decreases. So we're going to be at 220 here and then decreases. All right. So demand and supply. All right. The quantity supplied. How will the quantity of the product supplied change? So we're going to look at the supply equation only if the price is increased by 10. So the supply equation here, if I put a 10 in there, supply equation, how much does this change? Supply goes up by 5. Increases by 5. So quantity decreased by 5. Nope. Wait, look at this. B, I think that's already our answer, the letter B. C, the quantity increased by 10. Nope. Quantity supply increased 50. Nope. There you go. All right, now for number 18, it's the same problem. So I'll pause it here for a second. And then I'll show you the question. You can try to do this on your own. Again, we got our graph. It looks something like this. You know, supply, demand. We got supply here. We got our demand here. Okay. At what price is the quantity supplied equal? So they just want to know where these crisscross. Well, that's where the equations are equal. So we're going to take these two equations, set them equal to each other. So I'm going to say S equals 1/2 P plus 40 equals 220 minus P. So I'm going to get, let me see, 3/2 P equals 180, right? Because 220 minus 40 is 180. So P equals 2/3 180, which is 120. So letter B. Is there a quicker way without doing all that? Possibly, but I doubt it. I think that's probably about the best way you could do that. Okay, number 19. Now this is a totally different problem, not related to the econ equation. Graphene. Oh, I'll let you try to do it yourself. You can pause now. Okay, so let's look at this now. So a sheet weighing 1 ounce. So 1 ounce, 7 football fields. Notice I don't put an equal sign. I put a little arrow just to show what we're talking about. So 7 football fields. A football field is 1 1/3 of an acre. So 1 1/3, which is the same as 4/3. Okay. So you got 4/3 of an acre. How many acres for 48 ounces? So 1 ounce was 7 football fields. So 48 ounces times 7 football fields times our 1.3 bar. So just put that in your calculator. 48 times 7 times 1.333. I get 448, which is about 450. So there you go. Number 20. So you can look at the graph. And there you go. There's more of the problem. Now I'm going to do this. So Michael swam 2,000 yards for 18 days. for the swim that took 34 minutes. Okay, 34 minutes is right here. His actual heart rate was about how much less than the line of best fit. What's the line of best fit? The line of best fit is this straight line here. Okay, so at 34, the line of best fit here is at 150. But his actual is this dot here. So the actual is right here, which looks like 148. Because they go up by twos, 140 to 150. Be really careful, though. A lot of times, notice this, the graph starts at 120. Does not start at 0. So just be aware of that. Sometimes you can people get thrown off by that. So you got to look at what the relative values are across the top there. So anyway, 140, 150, 148. So the difference is 2. So the answer for 20 is 2. 21. Savings account, exponential. What does exponential mean? You know, that's like the amount you have in your account is some initial amount. You could just say P times 1 plus some rate times some T or something like that. It's just a general equation. Okay. Yeah. So each successive year, this is exponential, by the way, because you've got a rate, something changing, times the value that's in your account already, times each year. How much each year? So every year it gets compounded on itself. Each successive year, 2% of the initial savings is added. So in other words, if I have $100, 2% is added each year. So 2% of the 100. So it gets $2 this year, $2 the next, $2 next. That's not compounding because the dollar amount that's added to the account each year is not changing. Exponential means the amount that's added is changing, it's increasing. Exponential growth, increase. So we know that A cannot be the answer. 1.5% of the initial and $100. Again, it's of the initial, it's not of the new value of the account. So it's not going to be exponential. 1% of the current value. There, I like that one. Each successive year, that one sounds like the answer. 1% of the current value. So if next year, if you got $110, well, then the next year you've got 121 or whatever. I'm doing this kind of fast in my head, just making up numbers. But so 1% of the current value. So I like that as exponential. Let's look at D just to make sure. Each successive year, $100 is added to the value. No, because that's a constant amount again. It's not increasing. Therefore, it's not exponential. So the answer is C. 22. The sum of three numbers is 855. Okay, you can pause now. Try it yourself if you like. Now I'm going to do it. X plus Y plus Z equals 855. X is 50% more than the others. So X equals 1.5 times X, Y plus Z. Right? When you say 50% more, it's always going to be 1 plus the R. If it's a more, it's a 1 plus 0.5. If it's a decrease, it'd be 1 minus the 0.5, whatever that is. Okay. So we know that's there, that's there. Well, let's solve for X then. So X over 1.5 equals Y plus Z. Take this back up to there. So you get X plus X over 1.5 equals 855. And I can multiply 1.5 here, divide by 1.5. So you get, what do I get? 2.5x equals 855 times 1.5. And yeah, you're going to use your calculator on this guy. So I got x equals 513, which is the letter B. And the reason I'd use a calculator is that I think A and B are kind of similar. You know, they're not far enough away. If A was like 800, then you might not need a calculator on this problem. That's 22. 23. Here's two angles. Here's the question. You can pause it now if you want to figure it out yourself. So the angles shown above are acute sine of A equals cosine B. Something you've got to memorize. There are some formulas you're going to have to memorize on the SAT to do really well. And this is one you probably don't remember from school. So a lot of people just don't memorize this one. The sine of A equals the cosine of 90 minus A. Memorize this formula, okay? Now when we go back here, we can look and we see for this particular problem, B equals 90 minus A. So B equals 90 minus A. Simply because we've got that formula memorized, we can do this pretty easily. If we didn't have it memorized, we'd be in big trouble. All right, so now let's just start plugging in things. So A plus B equals 90. Right? We know A up here is 4K minus 22 plus B is 6K minus 13, and it equals 90. So 10K minus 35 equals 90. 10K equals 125. K is 12.5. The answer, letter C. '24. So I gave you time to pause to check it out. 24. So number of students. So it gives each student 3 milliliters of the solution. There's N solution originally, so N. He'll have 5 left over. So you got 3 times each student plus 5. Now give each student 4. So N equals 4 times S. Plus, you'll need an additional 21. Okay, so what do we got? We've got 2 equations, 2 unknowns. Right? So 4S, you can move that 21 to the other side. So minus 21. So 4S minus 21 equals 3S plus 5. So S equals 26. D. All right, number 25. Here's the picture. And I'll bring it down a little bit to show you so you can try to do this on your own. So now I'm going to do this. So what have we got? We've got some kind of crazy shape here, right? But notice these 2 cones are identical. So that's going to help us out when we do it. And let's go down here. So the grain silo, what is the volume of the silo? Okay, great. So it's pretty easy then. So the volume of the first one, if I'm going to do the volume of the cone times 2 plus 1 volume of the cylinder, right? So the volume of the cylinder is what? Pi r squared h, which is pi times 25 times 10. The volume of the cone is what? 1/3 pi r squared h, which is 1/3 pi times 25 times the h on this one is, this is a 25 here. And then the h is 5. But now notice there's 2 cones, so I'm going to say 2 times this one. So I'm going to make it a 2 and a 2. Okay? So you've got your volume of your cylinder, volume of your cone. So volume of the cylinder equals what? 250 pi. Volume of the cones equals what? Well, actually, because you have 2 times this, you could make that, still make that a 1/3, right? Multiply that times 2. So that's times 10, that's 250. So that's going to be 1/3 times 250 pi, right? So you got, so the total answer is 4/3 times 250 pi. Now, 4/3, now pi is actually very similar to 3. So pi and 3, so let's see. 4 times that is 1,000. So, you know, pi is bigger than 3, a little bit bigger. So it's a little more than 1,000. The answer is D. Again, you don't have to do a calculator. You could have if you wanted, but like I said, it takes a little bit of time. Number 26. And don't think, by the way, I'm ragging on you. If you want to use a calculator, you can. I'm just trying to encourage you, don't use a calculator a lot because it takes time to punch numbers in calculators. So you can try to do this one on your own, number 26. Now I'm going to start, passes through the origin, so we know the line is something like this. We got our X, we have our Y. So there's a point there, there's a point there, whatever they are. So we've got, it's Y equals mx plus b, but there's no b again. So Y equals mx. The first equation, 2. So you got k equals m times 2. The second equation, 32 equals m times k. Now, when you solve this, they're trying to solve here for the value of k. So we want to solve for a value of k. So let's make the m's equal to each other, you know, something like that. So what is this m here? So m equals k over 2. So 32 equals k over 2 times k. So 64 equals k squared, and that's it, right? So k equals 8. Letter C. '27. Rectangle was altered by increasing its length 10% and decreasing. Okay, so the area of the rectangle. Well, you know what? You do this on your own first. I'll pause a second. Try to do this on your own. Okay, here I go. Area of a rectangle is length times width. You've known that since junior high at least. Okay, area is length times width. The length, it's multiplied by, right? So what's the new area? Okay, so the new area is going to be equal to 1.1 times L, and then decreasing width by P. So width times 1 minus P. We don't know what the percent decrease is. It could be 10% or whatever. If these alternations decrease the area of the triangle by 12%, so 1 minus 0.12, so area of 0.88 equals 1.1 times L times W times 1 minus P. Now, remember up here, area equals LW. So the area here, this here, you could put a letter A from the top, and then those A's cancel. So you get 0.88 equals 1.1 times 1 minus P. And using your calculator, you'll get P equals 20%. Or letter C, 0.2. So actually, let me say this. To divide in your calculator, you're going to take 0.88 divided by 1.1, and then you'll solve for P. All right? Because you're going to get 0.8 here, and then that's 0.8 is going to equal 1 minus P, and you get your 20%. Okay, actually, you could have done that in your head, no calculator. Either way. Number 28. We're moving along pretty good. I don't know exactly what time we started, but again, I'm not trying to be stringent on the time because I'm trying to explain things. So you could try to do this problem on your own if you like. So the city's infrastructure, what is that? Infrastructure is building up roads, bridges, streets, things. Engineers starting from right now, the population of the city will decrease 10%. Well, decrease is 1 minus 0.1, which is 0.9. So that's going to be our factor, okay? If the present population is 50,000, so we're starting at 50,000. I already know that. We know we're going to be at 0.9. And then there's going to be something here in the exponent. So when I look at these answers, I see these two, they don't have a 0.9. So they're obviously wrong. So it's got to be one of these two. Now let's see, it decreases 10% every 20 years. So if I put a 20 in the answer, if I put a 20 in there for the t, it's actually going to decrease. So I need this to be a 1. Okay? That value is a 1 when I put a 20 in for t. So if I put a 20 in for t here, no, that's not a 1, is it? Right? So if I put a 20 years, after 20 years here, that becomes a 1. 1 times that's 10%. That's your answer. That's pretty much it. Okay, let's keep going. 29. So I'll kind of show the problem. You can try to do it yourself. Here's your answers here. So this is a probability, and we're going to have to count up some values, fill in the blanks here. They've left some blanks here. So let's see what this says. So there are 5 times as many right-handed female students as there are left-handed. 5 times as many right-handed. So the right-handed column is bigger. So we'll say 5 times F. So that's F. There are 9 times as many right-handed male students. So 9 times M. So M's going to go there. Okay. Total 18 left-handed students, 122 right-handed. Which is the closest? Probably a right-handed student selected at random as a female. So we're really going to be looking at this column here, that one. But you know what? We're going to actually have to solve for these. Let's solve for these. So we got 2 equations, 2 unknowns. So M plus F equals 18. 9M plus 5F equals 122. And I'm going to say, let's just do minus 5 times everything. So you do minus 5 times everything, and what happens? 4M equals, when you get 5 times 18, what do you get? 90? Okay, so 122, so you get 32. M equals 8, therefore F equals 10. So go back here, and so we plug these numbers in. So you get females, you got a 10, males, you got 8, so 50 and 72. So they want to say if it's a right-handed person, which is your 122, what are the odds the person is going to be female? So it's going to be 50 divided by 122. And use your calculator on that one, and you'll get this answer right here. 29 is letter A. Number 30. Pause a second. You can try to do this yourself. Okay, so what does this say here? B is equals, always, C minus 1/2. And I'm going to plug that in right at the top there. So 3x plus C minus 1/2 equals 5x minus 7 3y plus c equals 5y minus 7. So notice the only thing that's different in these two equations is this minus 1/2 guy here. So if we're trying to solve for x here, we could do that in this top equation. So you get c, I'm just going to bring this one down here. So you're going to get something like c minus 1/2 plus the 7 and equals 2x, right? So divide everything by 2, divide by 2. Okay, so x equals, well, let's just leave it like that. Okay, now let's solve for the y. So 3y, so you're going to get 2y on the right-hand side, c plus 7 on the left-hand side, c plus 7. So now y is c plus 7 divided by 2. So here, you've got x. X is all this. So what does x equal? X equals c plus 7 over 2 minus 1/2 over 2, which is minus 1/4. And we already figured out from this one that y is this, so you put it in there. So x equals y minus 1/4. 1/4 because we had here the 1/2. Hope you followed that. You can pause and rewind this if you need it, a little bit more clarification on that. But yeah, basically, it's kind of like 3 equations, 3 unknowns. A little more in depth than some of the problems we've done before. And that was, so the answer then for that is letter A. 31. By the way, that was our last problem that's multiple choice. The rest of these are fill-ins. Fill in your answers. I'll pause a second. You can check. So tickets for the school talent show is $2 for a student, $3 for adults. Chris spends at least 11, no more than 14. X students and 1 adult. Okay, so we're going to make an equation then. It's at least 11, so that less than or equal to, you got to put equal because it's at least, okay? Cost for a student is 2 times X plus the adult one, we already know it's $3, so just put a $3 in there. And that's going to be less than or equal to 14. Minus 3, minus 3, minus 3. So you got 8 less than or equal to 2x less than or equal to 11. So 4 less than or equal to x less than or equal to 5.5. So the answer then, really you've got 2 answers. It could be 4 or 5. You put it in either of those answers, you're going to be correct, okay? So I would just put in like a 4. But either one's fine. 32. The ages of the first presidents. I'm going to scroll down so you can try to do this yourself. Okay, now I'm going to do it. According to the table, what was the mean age, the average of these presidents when you, okay. So here, you're just going to use your calculator. Add them all up. 57 plus 62 plus 58, all the way down. Add up every single number. And then divide it by how many there are. 1, 2, 3, 4, 5, 6, 12. So divided by 12. You add them all up. Divide by 12. I got 58.58. And on the SAT, though, you're going to do 58.6 because you have to round it when you're doing these fill-ins. Okay, 33. You try to do this yourself at first. Okay, so when I'm looking at this here, we've got A, B, and C. You're going to look, each term you could think of separately. A, B, and C are constants. What's the value of B? So all I care about is the x constant. All right? Coefficient. Really, that's really what I should say, coefficient. They call them constants here, but the coefficient for the x here is a 5. What's the coefficient for the x here? Well, you've got to multiply minus 2 times a minus 2, which is a plus 4. So plus 4, which equals 9, and that's going to be your answer. That's the coefficient in front of the value for x. I don't care what the x squareds are. I don't care what the other one is. Doesn't matter. All right? All they ask you is the value of b, which is in front of the x, coefficient in front of the x. Okay, so that'll save you time. So hopefully you listen to that whole explanation there. Number 34. Try to do this yourself. So 34, what have we got? So you got 5 pi over 4 radians. The area of the sector formed by the central angle. Okay. So if I have a circle, here's my angle. That was bad. I'm going to redo it. So we've got a circle. And this angle is not to scale, by the way. Actually, it's the opposite. 5/4 pi. So it's actually greater than 180. But who cares? We're just trying to, just as an estimate. Okay. So if I said this is 5 pi over 4 radians. The area, this is something for you to memorize. The area of a sector here is always the same as the radians because a full circle is 2 pi. A circle is 2 pi. Now they're asking you, what is the fraction of the area of this radius? Okay, so the sector is 5 pi over 4. What fraction of the entire area? The entire area is 2 pi. So divided by 2 pi, right, equals what? Well, so I got 5 pi over 4 times 2 pi. Pi's cancel. You get 5 over 8. And that's going to be your answer. $35. Pause a second. Try to do it yourself. Okay, here we go. The average. Now this is a formula for you to memorize. I put sigma over n. Sigma, you're adding up how many values you have. N is the number of values you have. The quantity, okay, you could say the quantity. The average, what's the average? Okay, so we've got from 0 to 100, those are the possible values. The first 10 ratings received an average of 75. What's the least value the store can receive on the 11th? And we'll still be able for the first 20. So the new total is going to be 20. That's going to be your n. So we know the bottom here is going to be a 20. The new average is going to be 85. Now the first 10, it said was 75. So 75 times 10. This is what I would call the point value. How much did they add up worth? Well, it's going to be 750 of a value of the first 10. Plus, you're going to have your 11th, which will be our x. Plus, it says the least value for this one. So in other words, let's say they get 100 points on all the rest of them. And remember, there's going to be 9 more. So 100 times 9. Remember this quantity here, the quantity on the top has to equal the quantity on the bottom. The bottom is 20. So we have 10 here, plus 1 is 11, plus 9 is 20. So you got 20 different ratings added up on the top. This X rating, we don't know what that rating is for that middle one. So 10 plus 1 plus 9 is 20 divided by 20. There you go. Okay, so now I'm going to cross multiply 85 times the 20. So you get 1700 equals X plus 750 plus 900. X equals 50. There you go. Use a calculator if you want, but I think this is pretty easy to say 1650, right? Okay, number 36. Pause a second so you can try to do this on your own. So when I graph this, what do I get? So 3,000 and then decreasing. So let's just say 3,000 is here. This one here goes to the origin. So I'm just going to make this up. This one goes to the origin. It's going up like this. So notice also y is a less than, so the shading is on this side. This here is a less than, so the shading's on this side, right? Okay, so these are two inequality equations. Here's your x, here's your y. AB. What's the maximum value of b? Well, the maximum value where the shades intersect is this one right here. So a comma b. The b value is the y value, so I'm solving for y, where these two equations are equal. So set them equal. So, yeah, actually it's pretty easy to solve for x. So let's just do that one. So 5x equals negative 15x plus 3,000. And then what? So 20x equals 3,000. X equals 150. So y equals, you could use your 5 times 150, right? 750. So the b value, and that's the one we're solving for, is the 750. So the answer is going to be 750. That was 36. Here's 37. There's the top part of it. And I'll scroll down a little bit. You could read that. Try to do it yourself. So what have we got here? So our equation is n equals RT. Also, I want you to be aware that the R, average rate, is per minute. Be careful with your per minutes, okay? Because they trip us up when we do things that are different. And T was in minutes. So T minutes, R minutes, whatever. So now we've got 84 shoppers per hour make a purchase. So we need to change that. So 84 divided by 60 is 1.4 per minute. Okay? So 1.4 purchases per minute. Average is 5 minutes in the line. So how many people are going to be there? So you just take your 1.4 times the 5. Using your calculator, you get a 7. All right, 38. It's the same problem. I'll pause here. You can rewind to see the beginning of the problem if you need to. So, the owner opens a new store across town. The new store, the owner estimates business hours average 90 shoppers per hour. Oh boy, we got to change that to minutes, right? So what do you do for that? For 90 per hour, equals 1.5 per minute. And that's how many people enter. So 1.5 per minute. How many people stay? They stay an average of 12 minutes. So again, our capital N equals 1.5 times the 12, which is 18 people that are in our store all the time. Okay? Now, let's see what it says. New store, what percent less than the average number of the original store? Okay, so here's an equation that you learned back in junior high. And it's a percent change. So the percent change, you're going to say new minus the original divided by the original. So in this case, the original was, when we look at it, it was a 45. Now we've got 18. So you're going to plug this in. So you're going to say new 18 minus 45, all divided by 45. And that's going to equal what? What kind of a decrease? 60% decrease. There you have it. That was it. Check out the links below for other math help. We'll see you soon. Enjoy.